Since you are already enrolled in the Azure Security course, I am going to assume you have covered the fundamentals of the Azure Cloud, including Azure Virtual Networks, network security groups, route tables, user-defined routes, and network monitoring tools. In this video, we won't focus on deploying Azure resources. That's something you should already be familiar with before taking this course. Instead, we will look at key security and visibility considerations that every Azure security engineer should keep in mind. These insights will help you strengthen your network posture and maintain control over what is happening in your environment. Let's jump into the portal and see it in action. Now that you have gone through the basic of securing virtual networks, let's shift gears and talk about what you should look for when reviewing an Azure Virtual Network setup. On the screen, you will see a sample virtual network with multiple subnets. The first thing you need to ask yourself is, does this solution include a network virtual appliance like a firewall or a route server? If the answer is yes, then as a security engineer, it's your responsibility to ensure that each subnet is properly associated with a route table. This is crucial for controlling traffic flow. In this case, NHGs are still important, but you might manage most of the security rules through the appliance, like Azure Firewall. Even so, I recommend you to still apply basic NHGs with default deny rules to block any unwanted traffic from the open internet. It's an extra layer of defense. If the answer is no, and there is no virtual appliance involved, then NHGs become your primary security control. You need to make sure that each subnet has an NHG applied with granular rules, allowing only specific ports, protocols, and IP ranges. If NHGs are missing or too permissive, you got a potential vulnerability. Also keep in mind that not all subnets support route tables. For example, Azure Bastion subnet doesn't allow a user-defined route table. In such cases, you need to think ahead and apply alternate controls, like strong NHGs, to secure those segments. That's part of your job as a security engineer, such as understanding platform limitations and designing compensating measures. As for application security groups, I'm not focusing too much on them in this review. While they help simplify NHG rule creation, they are more about rule management than enforcing deeper network security. Another critical setting you should always check on a virtual network, especially from a security engineer's perspective, is the diagnostic settings. If you notice that this is missing, it means you, and more importantly, your security operations center team, won't have any visibility into what's happening on that network. You need to make sure that diagnostic settings are properly configured. In most enterprise environments, there is a SIEM solution in place, and the only way to ensure network level visibility is by forwarding logs from the virtual network to that SIEM. Azure allows you to send these logs to log analytics, storage accounts, event hubs, or other partner solutions. Whichever method your organization uses, the key is that these logs must be sent somewhere for monitoring and analysis. If this setup is missing, it essentially means that your SOC team is flying blind, and that's a major security risk. So always evaluate the configuration with this in mind. As a security engineer, it's crucial to ensure that your virtual network is configured with the correct DNS solution. One of the most common misconfigurations happens when teams rely solely on the default Azure provided DNS without aligning it with the organization's internal DNS strategy. This is often an overlooked aspect in many environments, and it leads to major headaches, especially when trying to get private endpoints or PaaS services to function properly. When DNS isn't correctly integrated, teams tend to implement workarounds and anti-patterns just to make things work. Unfortunately, these shortcuts often introduce significant security risks. So always validate that your virtual network's DNS settings are correctly aligned with your enterprise DNS infrastructure. Getting this right upfront will save your team a lot of troubleshooting later and help you maintain a secure and reliable environment. Another thing I want to emphasize in this foundational section is the importance of implementing flow logs, and more specifically, virtual network flow logs. My recommendation is to focus on virtual network flow logs rather than energy flow logs, because that's the direction Azure is heading toward. Virtual network flow logs provide cloud-native visibility into traffic patterns, which is critical for both security and operational monitoring. Unfortunately, this feature is often overlooked. Why? Because many teams assume that firewall logs are enough. But that's a common mistake. Firewall logs alone don't give you the full picture, especially for lateral or internal traffic. By enabling flow logs, you unlock the power of traffic analytics, which is a built-in tool within Network Watcher that helps you visualize, analyze, and monitor traffic trends. But you can only use it if virtual network or energy flow logs are enabled. As a security engineer, it's your role to advocate for this visibility and ensure traffic analytics is turned on. Not only will this help you monitor for threats and attack vectors, but it also gives your network and cloud operation teams a valuable tool for troubleshooting and optimizing network behavior. You will need storage account and log analytic workspace in place to enable traffic analytics. Ensure that you meet those prerequisites first. Now go ahead and search for Network Watcher in the Azure search bar. This will take you to the Network Watcher overview page where you will find all the tools we talked about earlier. At first glance, the dashboard might not show eye-catching visuals, but trust me, once the data starts flowing in, you will truly appreciate its value. Network Watchers helps you identify attack vectors, analyze traffic sources, and decide whether to block them using a firewall or an NSG. It's an essential tool for both security engineers and network administrators, which offer visibility and control that is critical in any secure cloud environment. This is all for now in the basic networking section. Hope you got a better understanding on various security elements that you can think of in the solutions you're looking after.